Good morning, everybody. Now, this will be my first class with you guys on Experimental Design 1, okay? Particularly STA 3108, okay? Now, like I said, I would love to start this particular class and end this particular class. That is, being the first topic, I would love to start it and also end it in this session. Huh? Now, so what are we going to be discussing? Just for a reminder, 3108 experimental design 1. This is the course title and this is the course code. Okay? So now the topic we shall be treating, which I will be calling my topic 1, will be introduction, definitions, and terminologies. Okay, so this is what I'll be treating. Is it clear? So we'll be looking at introduction, definitions, and terminologies. Once we are done with this, our next topic will be what we call completely randomized design. Is it clear? So more or less, this one we are calling a topic in experimental design 1 should ordinarily be just an introduction. But I want it separate because I believe teaching is like planting. As such, it is good the students are introduced to the course properly to enable them have a good foundation on what to expect subsequently in the course. Is it clear? So the question we want, there are so many questions we want to answer in our discussion on experimental design. Question number 1 is, to start with, we have to be very sure that everybody has a firm grasp or an aligned thought on what an experiment is. So when you hear the word experiment, what does it actually mean? And I would love us in this class to all have a convergent thought on what an experiment is. Okay? The second thing is this. Aside having a convergent thought on what an experiment is, the next question is, what then is the relevance of an experiment? What is the relevance of an experiment? When is one said to have carried out an experiment? And in this course, what are we actually doing? Now, another thing we want to answer in this introductory class is again certain notions. When you hear experimental design, and in particular experimental design 1 as STA 3108, take note, if there's experimental design 1, it means there's experimental design 2. Is it clear? Now, ordinarily, that shouldn't be. If you were treating the course as a whole, it should just be experimental design, not experimental design 1, experimental design 2, as the case may be. It should just be what? Experimental design. But take note of one thing, because of how cumbersome the outline is, it is best we partition them, all those outlines put together, it is best we partition them into 2 segments or more, such that in the first meeting of the students at senior level, senior undergraduate level, in this case the year 3 class or the 300 level class, one can actually look at the first part of experimental design, and subsequently, probably in their final year or 400 level, they can now look at a second part which comprises outlines that were not treated in the previous part, in what will now be called experimental design 2. Is it clear? Now, in doing that, there are certain notions one has to clarify. Now, you see, in real life, all of us usually answer what we call official names, we have what we call guy names or nicknames, right? We usually have those names. So some of you, by virtue of the ball you play and how well you play, some of them, your colleagues will be even calling you CR7. Some will, because of how poorly you play, they will even call you Maguire. You understand me? Your colleagues will start calling you Maguire if you play badly, or as a defender you are so bad. Forgive me, Maguire, if you are watching this video. So yes, you never can tell if Maguire will be watching this video. I'm only quoting what people say. I'm not quoting what I'm saying. Do you understand me? So Maguire, just in case you end up being a student in my class sometime in the future, forgive me. My students called you that, not me. So I'm blaming them. Now, so what I'm saying in essence is that experimental design is, let's take experimental design like an official name. Do you understand me? So the question is, what other names can we call this course aside experimental design? Such that if you call that name, instead of calling experimental design, somebody will still know that he's still talking about what? Experimental design. Is it clear? Now, aside that again, what I'm trying to do right now is to just mention to you, in this introductory class, we are segmenting to be a topic. All that we will be discussing, such that when we finish discussing them, we can satisfactorily say we have introduced ourselves properly to this course. Is it clear? Now, another thing is, there are certain definitions I will call underlying definitions that give credence to what we want to discuss. Such that, for example, if you skip these definitions to terminologies, in the terminologies, we'll be using certain words which we should have defined. And if we did not define them, when I am explaining this, when I'm explaining these terminologies, you will now start asking yourself, what does this mean in the terminology we use? I don't know if you understand me. For that reason, this topic is properly, or should properly be called introduction, definitions, and what? Terminologies. Is it clear? So, let's start with the very first instance. I would love to start with, this is 1.1. So, let's start with answering the question, what is an experiment? What is an experiment? Now, please take note. You see, there are definitions we call conventional definitions. There are definitions we call intuitive definitions. There are definitions we call experience-based definitions. Now, let me explain what I mean. What I mean is what will make you see what type of definition I'm actually giving you here. So, I'm not giving you to what an experiment is. I'm not giving you what I would call a conventional definition, such that you may go online and end up finding the exact same thing. The exact thing I'm saying, sorry. You may find the same thing I will give as my definition to experiment. The definition you find online just might be the conventional definition for what is called an experiment, in the sense that conventional definition is a definition that is universally agreed upon as the real meaning of a thing. Do you understand me? Now, if you move away from conventional definitions to a concept or to a terminology or to a particular ideology, you would go to what is called an intuitive-based definition. Intuitive-based definition will now mean what I feel about a concept. Do you understand me? My own opinion, my own take on a matter or a concept will be my intuition about that concept. So more or less in this class, what I'll be giving as a definition to an experiment will be basically a healthy mix of intuition and what? Experience. Aside intuitive-based definitions to experiment or to any other concept, there is what we call an experience-based definition. So experience, when you define a thing based on experience, it will mean that it is your overtime encounter with that thing that has built your own knowledge of that thing good enough to give a definition about that thing. Do you understand me? So, we want to start this class with answering the question, what is an experiment. So, an experiment may intuitively be defined as a carefully organized activity or set of activities in the course of an investigation, in the course of an investigation. That is or are targeted towards bringing about one, new knowledge, two, improved knowledge, and three, altered knowledge. Please, I'm going to explain what this means. So, my definition may become sweet enough to the international community, especially when they watch this video and hear me explain, and they may like my definition and make it conventional. So you can move from intuition and experience based to what? Conventional. Someday, and maybe they may name it after me. Yes. Now, let's explain this quickly. So, whenever you carry out what is called an experiment, please take note, everybody. What you are doing is to carry out a carefully organized activity or carefully organized set of what? Activities in the course of what you call an investigation. Do you understand me? Okay? And the essence of carrying out this carefully organized activity or set of activities in the course of what you would call an investigation is targeted towards doing any of these three things, not all of them at the same time. You see, let's look at it carefully. Some time ago, we were told that our forefathers, if you go biblically, were wearing leaves. Is it not so? They were putting on leaves. Genesis chapter 1, if you read down, and even chapter 2, if you read down, you will come to realize that one of the reasons when the first person who even created, after creating man and woman, putting them in the garden, was God himself. And he saw that they were naked, right? He saw that they were naked, but man did not see that he was what? Naked. You see it? We often will say necessity is the mother of what? Invention. Now, as soon as Bible recorded, they disobeyed, ate the fruit, which made them know the difference between evil and what? Good. They got to realize that they were marked in the Garden of Eden, such that they didn't know that they were naked. But now that they had eaten the fruit, they now knew that they were naked, and it gave rise to thoughts. Now that we are naked, man carefully thought about it. What do I do? The first thing that will come to your head when you notice you are naked is the answer to that question. If you are naked, what do you do? So cover your what? Your nakedness. And as such, they ran and made what? Clothing out of what? Leaves. You see it? Now, at that time they made clothing out of leaves. It was to them the best there was. Now, when you carry out an experiment, your experiment would always give an output. And the quality of that output could be that output is new knowledge. If it is not new knowledge that your experiment results in, your experiment may result in improved knowledge. Do you understand me? If your experiment does not lead to improved knowledge, it will lead to what we call altered knowledge. But in the course of any of these three, carefully organized activities will take place in what is called an investigation. Now, let me give you a quick example. In geography, secondary school, let's go back to secondary school. In geography, we were told that at some point in time, man felt that the earth was flat, such that he would move towards what is called the end of the earth and then fall off. Right? That knowledge prevailed and was sustained for a long period of time until it was disproved by scientists using aerial photographs from space, who now realize that whereas we are taught previously and over time that the earth was flat, what we are now seeing by virtue of aerial photographs from space is showing us that the earth is not flat, it is what? Spherical. And they developed theories from their findings which all put together alters the knowledge that what? The earth was flat. I don't know if you understand me. So now we are in our future, in our now and in our future, we have progressed from the knowledge that used to be that the earth was flat to what? An era where we now know that the earth is no longer flat, but what? It's spherical. So how did they get to that result which altered the knowledge previously? It was by virtue of what? Experiments. Do you understand me? So whenever you carry out an experiment, one possible outcome of an experiment could be that it could lead to what? Altered knowledge. Now, another example when it comes to improved knowledge. Why do you think that when a phone is produced today, before a phone is produced, take notes, this process has taken place. Nobody stumbles through an experiment. If they want to carry out an experiment now, the first thing they do is to look at this phone. We have produced, my own phone is ITEL P40. We have produced ITEL P40. They will let consumers experience the phone, the working of the phone, and after some time, complaints from consumers and complaints, they will criticize what they have even invented and start looking at it. What are the demerits? What are the flaws of this invention? And over time, based on the flaws and demerits of the invention they have created, they will carefully plan another activity which is primarily meant to do what? Improve the existing knowledge. There was a time, you will agree with me, that there was only one SIM in a phone. Now we now have phones that have what? 2 SIM, 3 SIM. Right? There was a time we never had what you call a touch screen. All you have were button phones. It is a carefully planned activity in an experiment that led to the result we can call improved knowledge. That is why a car is produced today, tomorrow you have new model. Tomorrow you have new model. New models keep coming out because as soon as one is created or invented, more work is done by virtue of an experiment in that investigation to see how they can improve that knowledge to bring about what? Improved knowledge. Is it clear? Now, again, sometime in our history, there was nothing called HIV. Most of the diseases you know today, at one point in our history, the history of man, medically, there was no sickness like that. Or the sickness may have been existing, but nobody knew that that was the name. Nobody knew that this was the working of this sickness. So probably they didn't even know that it was a sickness. Do you understand me? Now, it took also a carefully organized activity or set of activities in what they saw as an investigation. If one or two persons start developing symptoms they are not aware of, scientists will just bury their head into studying those symptoms, and they will start considering samples from a population to see who and who, what do you call it, portrays these symptoms. And at the end of the day, that activity may lead to something we never knew about. So an experiment, when it is carried out, it is possible an experiment will also lead to what? New knowledge. Do you understand me? So experiments don't only lead to new knowledge. If they don't lead to new knowledge, they could lead to improved knowledge. If they don't lead to improved knowledge, they could lead to what? Altered knowledge. So sometimes new knowledge is altered knowledge. Sometimes new knowledge is what? Improved knowledge. Is it clear? So whenever we carry out an experiment, it is geared towards getting these things achieved. That is number one. Let's move on to number two. Can I wipe this off? I hope you all got my point. The next thing we want to discuss. Now that we are told, now that we've been told the following. Now that we've been told the following. What in 1.2, what is the focus of this course? What's the focus of this course? Okay? Now, for us to, I hope everybody follows what I'm saying. For us to follow this course carefully, within this period of time, we shall be doing it at 300 level, and then eventually at final year level. You would need to understand, give yourself a clear direction. Now, for us to answer this question and to give ourselves a clear direction, please, everybody needs to know this. We need to now revisit that thing I told you earlier on, that this course has basically 3 names. So, I will start with those names, and with the name, you will get to know the direction of the course. So, I'm going to write here the course experimental design. The course experimental design. The course experimental design is another name for design of experiments. It's another name for design of what? Experiment. Meaning that if you don't call this course experimental design, what would you call it, class? Design of what? Experiment. More properly called design and analysis of experiments. More properly called what? Design and analysis of what? Experiments. Is it clear? So, like I told you earlier on, my name officially is John Effiong Hussein. Previously, my name was not John. It was Eswabanga. That was my name. It was changed to John in JSS 3 for reasons best known to me and my family. After that name was changed, aside answering John, my household name is Eteka. And my aunties from my mother's side till today, anytime we gather, they don't call me John. They don't know John. They call me Eteka. Now, if they call me Eteka, the question is, don't I answer? I do. Because that is my name. My colleagues in Lagos, my classmates, secondary school classmates, they have a name for me. I won't tell you that one. They have a name for me. And when they see me, they call me that name. Even though it wasn't the name given to me by my parents, I do what? I answer. You guys answer names amongst yourselves that you answer, even though those were not the names given to you by your what? Your parents. You know so? Now, in your various relationships, I know you have. Yes. In your various relationships, I know you have, whether intimate or non-intimate, casual or on intimate level 1, intimate level 2, Intimate level N. You have names you answer that your parents did not give you. Some of you answer baby. Some of you answer dear. Some of you answer cherish. Some of you answer love. Some of you answer this or that. Those names are not your official names. Yet, you bear them. Am I talking to people? That is the same way experimental design has a relationship in which it is called design of experiment. It has a relationship or an official name that goes as what? Design and analysis of what? Experiment. Is it clear, everybody? Am I talking to people? For that reason, it will shape the focus of this course. Now that we know that it answers any of these three names, I ended with saying it is more properly called what? Design and analysis of experiment. We can now say based on the foregoing, our focus in this course will be twofold. Namely, one, in the first focus, our attention will go to what? Design of experiment. In the second focus, our attention will go to analysis of what? Of experiment. Are we okay? Okay. Now, let's move on to the next thing I want you to know. Can I wipe this off? What's the problem? I can wipe it off. Now, I was expecting that somebody would ask me a certain question. Doctor or sir, this is not Europe. So I won't expect anybody to say, John, if it were to be in Europe or in the Western world, you will say, John, because my name is John. You know so? But here in Africa, it is considered a taboo to call people by their name, whether adult or what do you call it? Children. So, but what I'm trying to say is that there is a question I was expecting somebody would ask me. I don't know if anybody is thinking about that question. Has anybody thought along that direction? Should I give you a clue? I should give you a clue. Now, what have we discussed so far? We have discussed two items so far. Number one is to answer the question. We started this course with saying we should introduce ourselves to what? What an experiment is, so that all of us will be on one page. Now we have done that. Number two, we are now dealing with a course called experimental design. Leave the one aside, whether one or two. You are in experimental design. Now that we are dealing with a course called experimental design and we've given ourselves a clear understanding of what an experiment is, what will be the focus of experimental design? When I tell somebody I'm doing experimental design, what does the person expect from me? And we've answered that question by saying, first of all, let's know the real meaning of experimental design, the different names of experimental design. And based on its unofficial name or official names, we've come to realize that in experimental design, two things properly, elaborately should be discussed. Namely, design of experiments and what? Analysis of experiments. Now, if I were to be in your shoe, I would ask myself, come on. Experiment as a word is very, very all-encompassing. It is very broad. But we are in statistics. Is it that the way we see experiments is the way the social scientists, the guys in political science, the guys in management sciences, the guys in education, the guys in chemistry, physics, is that the same ideology they have about an experiment? So properly, there it is likely that the engineer may have what is called design and analysis of experiment. And they may hide that word engineering because it should be the design and analysis of engineering experiment. If the education person is carrying out an experiment, it should be the design and analysis of education experiment. Do you understand me? Because as you move from field to field, the perception on the word experiment should vary. It should change from field to field. As such, when you hear us in statistics say design and analysis of experiment, we are more or less referring to the design and analysis of what kind? Statistical what? Experiment. And that brings me, okay, so now, like I said, quickly let us revisit what I said earlier on. Now, you can look at experimental design in twofold, one of which is design of experiment and the other one analysis of experiment. Now, please take note that the experiment we are referring to is basically a statistical experiment. Now, if we say we are designing an experiment, in other words, we are referring to the design of what? A statistical experiment. So the question is, what the question should be, instead of writing what is a statistical experiment, the question should be, what is the design of what? A statistical experiment. What does it actually mean when we say we are designing a statistical experiment? So please, there are two ways to go about defining that or explaining that. So I'm going to put them under definition 1 and 2. Now, when you say you are defining a statistical experiment, it could mean, number one, it could mean that you are referring to, okay, so I could say a statistical experiment or the design of a statistical experiment is or refers to or maybe whichever one you want to put it. So the design of a statistical experiment is the planning of the experiment so that appropriate data may be collected for analysis using statistical methods to obtain valid and objective conclusions or results. Okay, so when you say you are designing a statistical experiment, it could be perceived from this angle. That is, one would think of you planning the experiment such that the data you collect is considered appropriate. Okay? And that data you collect is one that will be analyzed using what? Statistical methods. Is it clear? So when you are designing a statistical experiment, it is necessary that such an experiment should be analyzed using what? Statistical methods. And we hope in such a design of statistical experiment that the results or conclusion we will get must, number one, be valid, and number two, be objective. Objective in the sense that there is no interference whatsoever. It is not a sentiment-based result. It is not a false result. The results are true and devoid of your input. There are some, yesterday's inaugural lecture. The inaugural lecture that this man presented yesterday on something related to cobwebs in our educational system. I heard him say something that was of interest to me. I told you earlier on that the education people carry out experiments, you know, so he mentioned one of his experience, that's Professor Nsinoga. he mentioned in one of his experiences over time as a teaching practice supervisor. When he goes for teaching practice, he was surprised to see that the teaching practice students, knowing fully well that he will come as their supervisor to inspect how well they fared in relation to how they've taught the students, how the students have comprehended over time what they've been taught, that he was surprised that the students will be controlling the experiment such that they know the brilliant ones in the class. They will tear a sheet of paper and give these brilliant ones questions they will ask when he comes. Do you understand me? Now, that activity is supposed to be an experiment where him, the supervisor, will just watch and see. We have sent these people out for teaching practice, and presumably they should have taught, or they may have taught these students, and we are hoping they've taught them well. However, the supervisor does not come to see that you've taught everybody well and they all understand your teaching. Rather, he was saying that the interest of the supervisor is not primarily on those who understood. It's primarily on those who did not really understand. Let us see them clearly and know their problem. But he was saying that most of the teaching practice students will give papers, writing the questions they would ask the students when the supervisor comes, and the answers to such questions. And what were they doing? At the end of the day, that exercise, which is more or less like an educational experiment, will make the supervisor, if all the students answer the question very well, will make the supervisor think that the student who he came to supervise has done very well. Is it not so? And the kind of results you will be getting is non-objective. Because the conclusion that supervisor will leave with is that, the students did very well, whereas it's not true. So, when you conduct an experiment, especially that which is called a statistical experiment, we are saying it should be an activity that is devoid of your input. Let the experiment go naturally. Now, the man, I thank God, in his lecture yesterday, made it clear that when we come for supervision, let the class be the way it is and conduct that experiment. The experiment of you teaching a topic we have given you to teach, or a topic you bring up, and let us see the raw performances of the students to be able to run conclusions on their ability. Yes, the students were doing very well, some were not doing well. The ones that did not do well, we had to look for ways to make them perform well on a later date. Do you understand me? Those are conclusions that should be objective. Now, the conclusions also should be valid. So what we should be seeing from as an output of your experiment should be what? Be valid. There should be results that hold today, that hold tomorrow if you carry out the same experiment, that hold next tomorrow if you carry out the same experiment. But when the results are not valid and the results are not objective, it is most likely that either your data you collected for that experiment was inappropriate, or the methods you used in collecting that data was inappropriate, or you planned the experiment poorly. So, when we refer to the design of statistical experiment, we are simply saying that a statistical experiment involves what? The design of a statistical experiment involves the planning of what? The experiment, so that what will happen? Appropriate data may be what? Collected, so that what will happen? For analysis, using what? Statistical methods. And the essence of doing all that will be to do what? Obtain valid and what? Objective conclusions or results. So that is one way to perceive what the design of a statistical experiment is. Definition 2. You may perceive it, on the other hand, in this manner. Definition 2. A statistical experiment, or the design of a statistical experiment, rather, the design of a statistical experiment the design of a statistical experiment may also refer, please, can I wipe this off? The design of a statistical experiment may also refer to the planning of an experiment That is, if you don't want to state it in this manner, you may also refer to it as the planning of an experiment, so it may also refer to the planning of an experiment or the experiment, whichever one, so that certain set of experimental conditions imposed on experimental units are satisfied. Okay? So if you don't want to see the design of an experiment in this manner, you could also perceive it from this angle. Whichever way you state it, you'll be referring to one and the same thing by implication. Is it clear? Now, let's move along to the next thing I want to discuss. Now, the next thing I want to discuss is 1.4. Terminologies in DOE. Terminologies in DOE. Okay? Among several terminologies, we shall start, or we shall commence with considering the following below. One, factor. 2, treatment. And 3, levels or replicates or levels. Replicate or levels. Okay? Are we there? Now, please, may I wipe this off? Huh? Before we define them quickly, we are not too far from the end of my discussion in today's class, please. So sorry for taking your time, but let's see how we can progress to the end in understanding. So before we discuss these three, let me explain something. Look at it this way, everybody. Let's assume, you see in this definition, we made mention of experimental units. Please, could you look up? Now, let's assume that I have a plot of land. And over time, we've been planting, let's say, on this plot of land, we have been planting cassavas. Okay? And we've been doing that over time in an unplanned manner, such that we just plant normally, just for probably subsistence. That is, we plant and eat. Not for commercial farming. We just plant, but we harvest and then eat when it is due. Now, but we now decided on a certain day that we should not just go completely subsistent. We should go both ways. That is, we eat some, we sell some. So we go into semi-commercial farming. And for us to do that, we now realize that it shouldn't be business as usual. The status quo has to change, such that what we used to ignore previously, when we harvest, should not be ignored anymore. Now, we took careful observation of our planting season and our planting process and realized that on certain portions of this farmland, the cassava we plant is usually poorer in yield or quality of yield compared to other portions of the farmland. So the experimental, we now decide, okay, before we go commercial, let us use one planting season to observe this whole piece of land, so that it will now inform how to go about planting commercially in the next planting season. As such, the experimenter now decides to partition that plot, the whole farmland, into what he calls 4 experimental units. So you will end up having experimental unit 1, 2, 3, and what? 4. These experimental units in experimental design are called what? Plots. Do you understand me? So he partitions the farmland into what? 4 plots, considered as what? Experimental units. And on these experimental units, he will now impose conditions on them. Now, he would impose those conditions likely based on his suspicion. Probably, we put more fertilizer in this part. That was the reason why this part was growing very well compared to other parts. Probably this one here, this part here that is flourishing, even though we did not put fertilizer, was very close to a water source. Do you understand me? So it was, the yield there was performing. Then this other part, they will consider all those things, and based on those things, it will now inform what they call factors, treatments, and levels. Okay? Now, look at it this way. What you may consider to be a factor could just be your observation in this case, how you want to study the growth performance of every cassava planted on these 4 plots is in terms of probably their heights. You get me? And as soon as you consider height as the variable of interest, that height, if you denote it by x, becomes what we call a factor. Do you understand me? Now, if you consider height as the variable of interest, it now makes for height from plot 1, height from plot 2, height from plot 3, and height from what? Plot 4. Underneath, the 4 of them underneath what? X. Those levels of a factor you consider, x1, x2, x3, all of them height, but under 4 different levels, are regarded as treatment. You see it? Then, you will notice that, let's assume you planted 4 cassavas here, 4 here, 4 here, 4 here, 4 here. The repetitions of each measurement you take under each treatment is called a level or what? Replicates. Because it is considered a replicate in the sense that if you want to consider it now, let's say this is level 1. In level 1, you will go into each plot and take the measurement of each of these cassava. So I can go into level 1. In level 1, I will take this one, the height of this one, the first one here, the first one here, the first one, and the first one, the height, and I will record them here. You see it? So the height I will take here, this is a random variable. So the height I will take here is the first height under the first level. The height I will take here will be the what? The first height under the what? The second level. And I will do that for the first height under the third level and the first height under the what? The fourth level. When you now go into the second level, you will take the second height under the first level, the second height under the second level, the second height, sorry, this should be small, the second height under the third level, and the second height under the what? The fourth level. Is it clear? So these observations you take under each treatment are considered as what? Levels. From one angle, you can look at them as levels, but because you are considering them at the same time for each treatment, they are considered as what? Replicates. Is it clear? So that you will be hearing these terminologies again and again as you move through experimental design and analysis of variance. For that reason, just before we start using them in different definitions, it is better you know what they actually mean, because they will be reoccurring again and again. Sometimes some people may interchangeably use this one. They may call factors treatment and may call treatment what? Factors. They won't be wrong in certain instances. Please take note. But in certain instances, they are wrong. So you need to really know what these items mean. Is it clear, everybody? So let's now go through the following definitions. Please write. Factors. Factors refer to the variable of interest. Factors refer to the variables of interest. Factors refer to the variable of interest. Variables of interest for any population under study. For any population under study. Okay? Now, treatments. Treatments are levels considered under a specified factor for any given population under study. Levels or replicates are repetitions of observations taken under each treatment. For example, if the interest of an investigator was on the heights was centered on studying height discrepancies among undergraduate students of a certain department in Unicross. Then height becomes a factor. You see it? For instance, if the VC now says, come, let us carry out a study to see if the height of students impacts the academic performance of students in statistics department. The first thing we now know is that because height is the major focus of the study, height can be considered the variable of interest. As such, it will be the what? It will be the factor. Do you understand me? It will be the factor. So look at it. For example, if the interest of an investigator was centered on what? On studying, please put this, studying the height discrepancies among what? Undergraduate students of a certain department in Unicross. Then what does it mean? Height becomes the variable of interest. As such, height can be considered the factor. Is it clear? Now, let's go further. Now that we've taken these definitions, I want you to just understand how the definitions go. You get me? We started with saying in the first definition that factors refer to what? The variables of interest for any population under study. Remember what we had said previously in statistical inference, that the population, when we say a population in statistics, what do we mean? It is the largest, what do you call it? It is the largest set of observations or the largest group of elements or the largest group of entities under what? Study or observation. Is it clear? Now, if for a certain population, if we just say we want to study the height impact on academic performance of all the students in statistics department, automatically from year 1 to final year, all the students in statistics department, especially the undergraduates, will now constitute what we call a what? A population. But because for all of them from final year to first year, we are considering their height, that height becomes the variable of interest considered for that population. It now makes it automatically the what? The factor. Is it clear? So that's what I'm explaining in this paragraph. Now, in this instance, every level, every academic level, what am I writing here? Every academic level, that is in brackets 100 to 400, will constitute levels having observations or having a what do you call it? Heights grouped under variables such as x1, x2, x3, and what? x4. These levels of heights will be considered as what? They will be considered as what? They will be considered as treatments. Do you understand me? Because treatments are what? Levels considered under a specified what? Factor for any given population under study. Now, we are studying height, and height becomes our factor. But in the department, there is 100 level students. There are what? 200 level students. There are 300 level students. There are 400 level students. Each of those classes will give us what? Different heights. So, if you categorize all the 100 level heights, as many as they are, you have a variable x1 representing 100 level height. You have a variable x2 representing 200 level height. You have a variable x3 comprising 300 level height, and a variable x4 representing what? 400 level height. x1, x2, x3, and x4 will now constitute what is called a treatment, because they are levels under the factors that you want to consider. Now, in each of those treatments, you will now start saying, 100 level student 1, come here. You take his height. When you are done, 100 level student 2, come here. All of them are under 100 level, but you have 1, 2, 3 to n students under 100 level whose height you have to take. Each height, the activity is what? To obtain height, is it not so? That is the experiment. And as you take each height, for every height you take is a repetition of that activity, which is the experiment. So as you keep taking each height, you are repeating the experiment again and again. And when you repeat the experiments or you repeat the observations you've made from each object under a treatment again and again, you are referring to what? Levels or replicates. So they are repetitions of observations taken under what? Each treatment. So now we have talked about the treatment here. Let's now go to the level for that particular example. So what are we going to say? Lastly, in each of the levels, in each of the academic levels regarded as what? Regarded as treatment, observations, height observations taken on each student or taken on each student repeatedly will make for what? Will make for replicates. Full stop. Will make for replicates. Are we there? Now, so I hope everybody understands those three terminologies. I hope you understand. Can I wipe this off? Huh? So, let's now move quickly to the next item. That should be 1 point what? 1.5. So in 1.5 now, please write basic principles of experimental design. Basic principles of experimental design. $1.5, right? Basic principles of experimental in any experiment, the interest of the investigator, in any experiment, the interest of the investigator is to conduct a well-planned experiment, a well-planned experiment that gives results, which are the same as the ideal or near ideal. So students will, what do you call it? You carry out an experiment. For example, when this phone is to be produced, there are certain expectations. Take note, not all expectations put together that they wanted for this phone came out as planned. Do you understand me? If not, if everything as idealized came out as planned, there will be no need for upgrade. So what they usually would do is, when you want to carry out an experiment, you have what you would call, the layman would call hope. What your hope is for the results. Your hope is that the result should come out as this, which you consider the ideal result. But oftentimes, when the result comes out, it comes out divergent from the ideal result. Probably, it could come out divergent in the sense that this is the ideal result and this is where your result is, such that the gap is very far. It will come out in the sense that the result you got is the same as the ideal result. It is a possibility. So there are several possibilities, but the experimenter in statistics would want the ideal result to be the final result to be the same as the ideal or very what near the ideal. Is it clear? Now, the divergence of an experimental result from the ideal is considered an experimental error. And the statistician hopes to minimize, if I didn't spell that minimize correctly, please know that I'm writing minimize there. Minimize. Hopes to minimize this error as best as he or she can. Full stop. Okay? Hence, experimental error can be considered as the sum of two types of errors. Okay? Whenever there is an experimental error, two types of errors amount to it. You know what they are? One error will be coming from what we call systematic. Systematic errors will pop up, added to what we call random errors. Okay? So these two errors put together, whenever an experiment is carried out, they are always present. So the aim of the statistician is to reduce these two errors as best as he or she can, because he knows that what makes up for experimental error is a combination of what we call systematic errors and what? Random errors. Now, the question now lies in the following. What are regarded as basic principles? What are regarded as basic principles of experimental design are principles geared towards reducing, minimizing, or eliminating experimental what? Errors. Okay? So what we now refer to as the basic principles of experimental design are those principles you implement in the course of implementing what? In the course of a statistical design of a statistical experiment to reduce what? Experimental error. And by reducing experimental error, it means you are either reducing what? Systematic or random or both of them. Is it clear? So the question now is, what are those principles? What are regarded as basic principles of experimental design are principles geared towards what? Principles that are geared towards reducing, minimizing, or eliminating what? Experimental errors. You could say principles that are implemented for reducing or minimizing or what? Eliminating experimental errors. And you now know that experimental errors are made up of two components. Okay? Now, what are they? These principles are: one, randomization. So randomization principle, if you tell somebody that you are doing experimental design, one question they would always ask you is not define experimental design. One question they would always ask you, once you just tell somebody I'm doing experimental design, they will just ask you what are the principles of what? Experimental design. Is it clear? So you must know. Number one is what? Randomization. So randomization is a principle of what? Experimental design. What does it do? It is a principle that will help us minimize, reduce, or eliminate what? Experimental error. How? We'll leave that one first. 2. The next principle is what? Which one? The principle of the principle of replication. The principle of what? Replication. Replication principle is another principle in experimental design. Remember, there are other principles probably, but we are using what? We are referring to what? The basic principles. Is it clear? Some other people may have their version of what principle should be added to this basic principle, but we are referring to the basic principles of what? Experimental design. Randomization, replication, all of them, we have just said that all the principles, irrespective of what they are, they all do one thing. They reduce this. Is it clear? Now, the third one is the principle we call blocking. Okay? So principle number 1, randomization. Principle number 2, replication. Principle number 3, blocking. Is it clear, everybody? So let's stop there. We'll continue in the next class. Your faces are